Okay, hello ladies and gentlemen. What we're going to do is we're going to talk about two formulas. The first one is permutation, all right, which is this one right here. This is permutation, and this one right here is combination. Now notice, N is what you have, K is what you want, all right, and that goes for both combination and permutation. I'm going to show you a scenario here in a second of how I'm going to use both of these. All right, so here we go. Now, on this one, again, like I said, here are the two formulas. Now, let's go ahead and read this right here. On the way home, you decide to stop by 28 Choice Ice Cream Parlor for a snack. With 28 flavors to choose from, how many different ways are there to order? And the scenario is a cone with 2 scoops of different flavors, if you care about the order of flavors. All right, so here order matters. The second scenario is a cup with 2 scoops of different flavors if the order doesn't matter. All right, so here we go. A number 1 or number A, we're going to talk about permutation. Now, notice, here's the formula. It's NPK, which is n factorial over n minus k factorial. Now, on this one, you've got to understand, all right, ask yourself, how many flavors do I have? Well, I have 28. How many do I want? Well, I want 2. And again, order matters. So, in this case, our n is going to be 28 factorial over 28 minus 2 factorial. Now, 28 factorial, I'm going to write off to the side. 28 minus 2 is 26 factorial. Now, remember, there's a little shortcut we can use. This is the same as saying 28 times 27 times 26. Now, instead of writing 26 times 25 times 24 times 23, I'm simply going to write 26 factorial, because this would continue all the way down to 1. Now, I'm also going to leave this down below. And since this is multiplication, I can now eliminate 26 factorial, which leaves me 28 times 27, 28 times 27, which is 756. So there are 756 possible combinations for the first one. Now the second one is with when order doesn't matter. And so that one, I'm going to use a combination. Now remember, the formula for this one is very similar. It's n factorial over k factorial and then n minus k factorial. So now I'm simply going to plug in the n and the k. This is n, the 2 is the k. Same thing, 28 factorial over 2 factorial. And in this case, it's going to be 28 minus 2 factorial. So I get 28 factorial over 2 factorial. And then 28 minus 2 is 26 factorial. All right, so now what I end up having is 28 factorial divided by 2 factorial times 26 factorial. I'm going to do the same method as I have up here. Well, actually, I'll try a different method here. This is the same as saying 28 times 27 times 26 times times 3 times 2 times 1. Now, I'm going to put that over. Here's my 2 factorial. But I'm going to do 26 factorial like I did the numerator. So this is going to be 26 times 25 times times 3 times 2 times 1. Now, notice that these are the same. So I'm going to eliminate 26 through 1 because it's all multiplication. And what I end up with is 28 times 27 over 2 factorial. Now remember, 28 times 27 is 756. And then 2 factorial is 2 times 1, which is just 2. So when I divide that by 2, I end up getting 378 possible choices. And that is how you work permutation versus combination. All right? Now, one of the other things is, from the book, you have this scenario. Well, if you want the probability of getting an ace or two aces? Well, one method is to use your tree diagram. The other method is to use permutations. Now notice, the probability of two aces is what you want over the total number of outcomes. So what we end up doing is this. Let me blow this up here for you. All right, so what I want is an ace. Well, there's 4 aces in the deck of cards. I want 2 of them. So that's what I want. Then there are the total number of cards I have, there are 52. I want 2 of them. So again, it's what you want over the total number of outcomes, or what you have. So I'm not going to go through the mathematics, but it ends up being 4 times 3 over 52 times 51, which is 0.0045. Now, let me show you how you work combinations. Combinations is pretty much the same thing. We're going to use the same method, except order doesn't matter in this case. Again, what I want is 2 aces. What I have is 52 cards. All right, so it's the number of ways to get 2 aces over the number of ways to deal 2 cards. Now, I have 4 aces. I want 2 of them. So when I plug that in, I get 4 factorial, that's your n factorial, times divided by k factorial, that's the 2 factorial, times 4 minus 2 factorial. And you can see how it plays out. It comes down to 6. On the bottom, I do the same thing. Here's your n factorial, which is 52, divided by k factorial, times n minus k factorial, and then I simplify it all the way down to 1326. And then when I divide that out, I get 0.0045. Now, I want you to try and practice these problems that I've given you for the day, and we'll discuss them when you come to class tomorrow. And by the way, those problems happen to be, let me show them to you. All right, remember, permutations are problems 1, 2, 3, 9, and 10. The combinations are 4, 6, 8, 11, and 14. But I want you to do both sides of the worksheet.